I hate being interrupted so rudely, but I guess if I watched the clock a little more closely, I would know when I was coming towards the end. But as you can see, these esters are the ones that make up the different artificial flavorings, because these and they call it, they just isolate these particular chemicals, but these are the ones that are actually present to give the flavor to these different materials. These are common in plants and animals. The lighter molecules have characteristics, odors, and flavors. Yes, that's because we do smell those. And the heavier molecules are odorless fats and oils. Oops. Just a second here. Let me get done with the slideshow. Okay, now we can continue on. Organic acids, this right here, they have showed the little ants here because the formic acid is what is injected by the ants that causes the sting. This is the ethanoic acid or acetic acid. This is methyl ethanoate. This is the chemical official name. These are the more common names. This is methyl acetate. And here you have is this is a weak organic acid, and titrating with sodium hydroxide will give you this particular ion with this, and of course water. And of course, because this is a weak acid, when this reaches this equilibrium point, as we learned, as you will learn in your lab today, it's a little above pH 7. Well, when you have a weak acid being titrated with a strong base. This right here is how one of the esters are formed. You actually take the acid to begin with, and then take some alcohol, and you'll see that this group right here is what will form in place of this hydrogen right here. So you lose this OH and this H for the water, and this portion of the alcohol is what goes right here. This is the ethanol, right, group right here, and this is the acetate, right? So acetic acid becomes the acetate portion. This portion right here becomes this part of the ester. And this has, again, a lot of the different ones. This also includes the methyl salicytate, which is the wintergreen. Methyl phenylacetate is the honey. Strawberry is ethyl methyl phenyl glycidate, right here. This one right here. Orange is octyl acetate. This is benzyl acetate. So it depends upon what you have coming off at this point right here. If it's a benzene ring, it smells like a peach. If it's just a chain out here, okay, then it smells like an orange, okay? The last section right now are the amines. Ammonia, you can have an organic group with a methylamine here, okay, where one of the hydrogens on the ammonia has been substituted with an organic. Here you have two different carbon groups on that, and so this is a dimethylamine. And this right here with three of them substituted for the hydrogens would be a trimethylamine. So an amine essentially is a carbon group with a nitrogen with 0 or to 2 hydrogens associated with it. And you can see the way in which these work. So you have ammonia to get the ammonia ion, methylamine to get the methylammonium ion. And if instead of just a straight, if the carbon that's attached to the nitrogen has a double bond oxygen attached to it, it becomes an amide. So that's the difference between an amine and an amide. An amine would just have another carbon or a hydrogen here. An amide has a OH attached to that amine group. Okay? And the way in which they're formed is the following. You take that carboxylic acid, you react it with an amine, and you get an amide, okay? And here is sort of a summary of all the different compounds, as well as what the functional groups are for them, and what the names are for them. This is a handy little reference table you might want to print out. Now, organic compounds are the compounds of life, okay? The small molecules use energy and matter surrounding to build larger macromolecules, right? Back in biology, you had the photosynthesis process, where incoming light hits the leaves in the tree, and it converts the carbon dioxide and water into glucose for sugar, right? And then other enzymatic processes, which are proteins, allow you to convert that into a variety of other materials. And the type of macromolecules are proteins, carbohydrates, fats and oils, and nucleic acids. These are the 4 types of building blocks for life. For an amino acid or a protein, what happens is you start with an amino acid and combine them together. And there are about 22 common naturally occurring amino acids that form the different proteins and enzymes that make up. So here's the way in which they're formed. This amino acid contributes this group right here and this hydrogen right here, okay? So these form water, and whatever this one happens to be becomes this portion of the peptide, and this one portion becomes this portion of the peptide. So this is and this can continue on and on and on to get a polypeptide chain, and a polypeptide chain of long duration is just a simple protein. So it's a combination of these these carbonyl groups and these amine groups, the carboxylic acid group and the amine groups here, okay? So this is the way in which they are formed and the form of them. And for example, when you have this one right here, this right here is cysteine, okay? And this is valine, and this is lysine. Lysine plus this one. And the most common one is the one that makes up the 2 for the aspartame, right? That's a very common 2-peptide sweetener that is formed. So insulin has 86 amino acids in the chain. Somehow that got stopped, and I'm not certain why. Be that as it may, this is for the polymerization reactions, and with a catalyst controls the length of the polymer, or in other words, the molecular weight distribution of the different ones, which give them their different melting points and their strengths and the utility in the different applications. Polyethylene, this is in squeeze bottle containers, laundry, trash bottles. Polypropylene, what if it's like this? This is the outdoor carpets. Bottles are made from that one. It's stronger than this one. Polyvinyl chloride, this is plumbing pipes, synthetic leather, phonographic records. These are the old vinyl records that your grandparents talked about. Polyvinyl acetate, this is an adhesive and a resin and paint. Styrene butadiene, this is in automobile tires. This is for ABS. Okay. And then you also have polyvinylidene chloride. This is a flexible food wrap. This was the famous by Dow. The Saran is its registered trademark. Polystyrene, also Dow. Styrofoam, the styrofoam is actually the trade name for the foam sheets, not the little beads. Anything that's made out of bead is just a polystyrene bead. And this is a Teflon. This is polytetrafluoroethylene. This DuPont was the one who made this one. Plexiglass, lucite, that was both DuPont as well as Union Carbide. And this was also Union Carbide on this polycarbonate right here. And polyacrylonitrile, this is your Orlan, Acrylan, textile and fibers are made out of this. This is a very, very tough material, such as motorcycle helmets. This one right here is the transparent plastic glass that they have for this one. Also, you'll notice is that if you look closely on different plastics, if it's made primarily of one material, what they can do is the number will tell you what type it is if they don't have the other ones or what these symbols stand for. But it tells you what the different ones can be used for and then how they can be recycled. So it's a good way to reuse the things that we have. Let's continue on now with Chapter 3, Nuclear Reactions. The idea here is that the nuclear reactions involve changes to the nucleus of the atom, okay? So any other chemical reaction other than these did not change what that nucleus was. And so if you had a certain element on one side of the equation, that same element had to occur in the same number on the other side of the equation. Now what we're getting so that the number of protons on one side of the equation has to equal the number of protons on the other side of the equation, right? Well, actually the protons and neutrons on one side have to equal the protons and neutrons on the other side. And what happens is some of the elements, especially those way at the bottom there, all of those that were listed in white on the table that when we talked about that, undergo spontaneous emission of particles or energies from an unstable nucleus. These were discovered by Becquerel. Madame Curie did an extensive amount of work in this area as well. Three types of radioactive decay are alpha decay, where you get a helium nucleus out of there, beta decay, where you get a high energy electron, gamma decay, where you get a high energy electromagnetic radiation. So 2 with particles, 1 with just radiation. Okay? And what happens is you can separate them. Alpha particle will go one way, the beta particle will go another way. This is positively charged because essentially what you've done is you've stripped that helium nucleus from electrons. This is a beta particle, negatively charged, and this of course has no charge. So the atomic number equals the number of protons in the nucleus. The isotopes are the same atomic number but a different number of neutrons, right? And the mass number is the number of nucleons, protons plus neutrons in the nucleus. This is just a review of what we learned many, many chapters, well, I guess a few chapters ago. So what happens is these nucleons, when uranium undergoes a nuclear reaction, it goes to thorium and helium. This is your alpha particle right here. That you don't, and this is the number of neutrons plus protons is 238. The number of protons is 92. This changes, so it loses 2 protons, and it also loses this goes down by 4. So it's losing 2 of the neutrons as well. So that's why this is 4 up here. 2 neutrons plus 2 protons to give you this material right here. So the charges add up down below. The number of protons add up down below. It's not really charges. The number of nucleons, or the neutrons and protons, add up above as well. And so what happens during one of these chemical reactions is is the mass number of 1, so this is a charge of 1, electron of 0, so this is a -1, a neutron is 1, so this is 0, and a gamma is 0, and this is 1. Okay? So this is the way in which those things work. And I think we're going to stop there and we'll start the next unit with this one.